Fran Lab. Muzikba says he's considering making PCBs for a project in KCAD. Wouldn't mind some advice. Well, I used Protel. I still use Protel 99. But I mean, yeah, all the software is very similar. I've done tutorials years ago when I was doing circuit boards more readily, and when I had readily available setups to do etching. Still, I did some videos from the basement lab. I'm talking about before the 1.0. I did a series showing my process of making boards, but rather than using the persulfate, the sodium persulfate solution, I used ferric chloride just because it was convenient. It's not as pretty, but it's just easier to use because you can keep it in the bottle, use it, and then put it away. But I have all the steps there about how to make the transfers, transfer them. I use a t-shirt press, which if you're going to make your own circuit boards is the way to go, using the heat transfer method with a shirt press. And I have a very specific method to use that because I use steam. So I'll print this one out here. You set your printer to have the densest settings, whatever the setting is, like the densest print, darkest print, when you print these out, that you do want to get the maximum amount of toner. And by putting on the light box, you can check for errors. If there are gaps or breaks in the traces, you're going to be able to see them, and it'll be easy to reject a printout rather than actually going and putting this onto a piece of copper and then discovering that the traces. First thing I do is clean off the copper board with some denatured alcohol. It gets rid of all the residue and oils and stuff that will end up being on the board from the manufacturing process, and you need to get it clean for the toner to adhere. I cut back the artwork to a tight fit, leaving one end longer than the others because you're going to need a longer end as a tab to sort of be able to get the artwork off when it's pressed on. It's also a very good idea to wear gloves during this whole process. You don't want to get fingerprints or body oils on the copper or on the artwork during this whole process. I build up a sandwich with some cardboard. I just use some manila folders. Put the artwork on top of the copper, put a piece of paper, and that makes a completed sandwich, and the artwork and copper won't move around as you do the rest of this. I soak a piece of heavyweight 100% cotton denim in the water pan, and I lay that on top of the sandwich and kind of take out the wrinkles. And that saturated cotton denim then goes into the heat press. The heat press is preheated to 165 degrees Celsius, and the water in the cotton instantly turns to steam, which will vent out. And it's the steam that actually creates the heat transfer into the copper-clad board and adheres the toner very, very quickly. And I leave the whole sandwich in the press for about 90 seconds. And after 90 seconds, the water is completely gone, and I can pull out the sandwich. The reason you need the manila envelopes there is everything's very hot now, and you have to grab the edge there to pull out the board, and it goes into the water pan, cold water, and in about 10-15 seconds that board is cool and at room temperature. And just get a little piece of paper towel to blot the whole thing dry, get the excess water off. Again, take great care in doing this because this the press is extremely hot, and the board and the artwork and everything else are extremely hot when they first come out of the press. And then with the long end, just a slight little pull, and you peel off the blue backing, and it's done. A nice adhered board. Works good every time. Now using some heavy-duty metal snips,
I cut back the FR4 board very close to the artwork. The reason you want to trim away any superfluous bare clad board is to conserve the etchant. When these boards go to etch, every little bit of copper you can conserve is going to allow your etchant to last that much longer. So I use these heavy-duty snips because I can get right up to the artwork and make a really clean, crisp, sharp cut through the FR4 board. You can see it's pretty close. And I've done 3 of these. These are ready to etch, and the 3 bare boards will yield me 120 individual printed circuit boards. Okay, so now we're ready to etch, and etching means using chemistry, and if you use chemistry, you're really going to want a vent hood. A vent hood is just a controlled environment that allows you to work with chemicals, and it constantly pulls in air into the box and vents away the fumes of the chemicals you're using, and prevents contamination of your workspace and yourself with the chemistry. This one I made myself, and it's really inexpensive and easy to do. I just got like a regular store-bought storage tub from the home supply store and cut a little window in the bottom, turned it upside down. I also cut a little hole in the top and for a tight fit with a regular off-the-shelf 4-inch dryer duct and it just pressure fits right in the top there, and that goes to a little adapter that just plugs right into my exhaust fan, which I'll show a close-up of in a minute. Okay, so this is the exhaust fan. I've got a cover here. It's a draft cover because it is wintertime and the cold air comes right through. But I put a hole in the wall and and just ran this right outside. It's got a regular speed control, which you just get, right from the store. Pretty simple. And it just plugs right on, tight fit, like that. So there's a few different ways to go with etching. There are several different chemicals that people do use. Some people use solutions of hydrogen peroxide. I have used sodium persulfate. But I only use that for doing large numbers of boards because it is a little involved making an aqueous solution of sodium persulfate and in an etching tank. And probably later on, when I do a large run of boards, I'll show how to set up an etching tank so that you can do large volumes of boards with sodium persulfate. But most everyone who's going to do a one-off board, they're going to use ferric chloride. And usually buy it in a little bottle like this. This is 16 fluid ounces, about half a liter of ferric chloride. It's concentrated. You can dilute it, but if you decide to dilute it, you're going to want to dilute it with distilled water, not tap water. But the way I'm going to show you to do it, you just use a full strength. If you're just etching one board or a few boards, the best way to do it is in a pan. Okay, it's going to be a little loud with the vent running. One thing you're going to want to wear is long protective gloves. These are very used, but thick gloves. This is when you're working with chemicals, you don't want to use those sorts of thin latex gloves that you get at a pharmacy. You want to use something for chemicals. I recommend nitrile gloves or gloves that are made specifically to handle solvents and oxidizers, which ferric chloride is an oxidizer. Okay, so I've got one pan. This is a 5 by 7 inch photographic developing pan, and got another tray here that's just filled with water, just regular tap water, and that's for the rinse because you're going to want to put it in there. I have a pair of just regular bamboo photographic tongs, again, just to pick the board out of the etchant and put it in the wash to let it to wash the board after I etch it. And this is one of the boards that I made up in the last part. I'm just going to lay it copper side up in the tray. And then I'm just going to add enough ferric chloride just to cover the board, maybe no more than 1/4 of an inch thick. And I'm just going to, with a little motion, just keep a wave motion going over the board. That's going to allow the etchant to keep flowing over the copper and keep removing a steady, a constant layer off the board. Every now and then I'm just going to take a soft bristle brush and just brush the surface. And brushing the top of the board just very lightly, it just skims off the gunk that builds up on the board as the ferric chloride etches out the copper. It's been about 15 minutes, 20 minutes at room temperature with this full concentrated ferric chloride. And if I lift the board out, you can see that the traces are visible. So it's almost done. I'll give it another 5 minutes or so. You want to make sure that all the little bits in between the traces are fully etched away. And if you pull it out and rinse it and see that it's not quite etched all the way, well, as long as you haven't taken the resist off, you can just put it right back in the pan and keep etching it, and then rinse it again. It's been about 25 minutes now, and the ferric chloride is very, very dark. Looks like it's completely etched. All etched out, nice and crisp. All the through holes are etched through, and that's really the best indicator for when it's done, is if all of the little drill holes that you have in the board are cleared, because you're going to need them to be cleared to know where to drill. Okay, now that the boards are etched and ready to move on, we're going to take the resist off. The resist is toner, which is pretty much plastic, so best way to get it off is with just regular nail polish remover, or you can use pure acetone if you're hardcore, and just some regular cotton pads. You know, be very generous with the remover, and it'll just wipe right off. Just a little finishing buff, just to get the last little bits of toner off. And that's pretty much it. There you go. Nice clean board. And that is ready to drill. Hey, it's Fran. Again for part 3 of our 3-parter. This one is about drilling. And drilling is probably the hardest part of making your own circuit boards. This is my drilling station. Now normally I've got a shroud bolted to this filter that creates that same flow of air that I have in the vent hood that keeps air moving towards the filter to take the airborne dust out of the work area when I'm drilling. If you're only doing one board or a few boards, you're not going to need that kind of elaborate setup. But if you're doing a lot of boards or doing your own circuit board production, then if you spend 3 or 4 hours a day at a station like this, then it ends up being quite an issue with the dust, because you don't want to be breathing in FR4 dust at all. It's mostly glass, and the human body doesn't take to inhaling glass powder all the time. It's just, yeah, there's bad stuff will happen. You're going to have to protect your eyes and protect your breathing when you're drilling. I always wear my safety glasses, super geek. So you have to make sure that you protect your eyes. And because you're also going to be very close to the drilling, you're going to be breathing up the dust, so you got to wear a dust mask. When I do like in volume drilling, I tend to wear an actual respirator like this. The most important tool in drilling is the drill press, and I've got this Accurized jeweler's drill press. It's not just smaller than your average drill press, it's also much more accurate. Although I actually had to accurize this press to make it more precise than it was out of the box, because I used tungsten carbide bits. Most of the demonstrations, in fact I think all the ones that I've seen about do-it-yourself circuit boards, people use the larger high-speed steel bits, which is fine, but you can't get a very small hole with a high-speed steel bit. They just don't make them that small. And where steel bits will flex slightly, which means you can use an inaccurate press and the bit will flex around, you can't flex tungsten carbide bits. Okay. This is a typical bit that I would use. This is a 33 mil bit, which is standard for my through-hole stuff. I'm a big fan of making the hole size comparable to the lead size, and 33 mils is pretty standard for most through-hole components. But if you do through-hole boards, you need an assortment of sizes. And this is a typical assortment, lots of different sizes ranging up to I think 50 or 60 mils down to some 25 mils. The reason that's a good idea to actually match the hole size to the component lead size is that you just get a much better fit. The smaller the hole can be, then the more copper you have on the solder pad, the better joint that you're going to have, and it's just a better idea. Rather than having oversized holes which cause your component to slop around, it won't stay in place when you're soldering it, and you don't get as much copper to adhere the lead to. But tungsten carbide bits are quite brittle. They're extremely strong. They'll drill through glass, but they're also brittle. So the trick with using tungsten carbide bits is you can't have any run out. When the bit spins, it has to spin exactly on its axis to within a couple of mils. If the bit's wobbling around in the chuck, it's just going to shatter as soon as you try to put it through something. So you have to have an accurized press. And drilling itself is a little challenging. You're going to have to take into consideration the board size. So these large boards that I made, these are from the 4x6 blanks. I cut these down to drill them, just using my regular tin snips, I cut them down into smaller bits that were easier to handle and manipulate in the drill press. My press also has a depth stop, which is also handy, so that when the bit comes down, I can set where the bit actually stops, so that I can set the bit to stop just after it goes through the board, and it also gives a nice tactile feel, so that I know when I'm through the board, just because I've hit the stop, and I can reverse and go to the next hole and hit it again. This also is a handy little tool. I made it out of a very typical, I'm sure you've seen these before, these little helper tree type thingy, the base on it and the little clippy things and maybe a magnifying glass. I just modified one of those and changed the armature here to hold a plastic straw that I've bent with a heat gun. And all this does is it hooks up to the output of an aquarium pump, right, regular aquarium pump, and the output of that goes to the straw, and I use it just to blow air right at where I'm drilling, because what you're going to find is when you're drilling FR4 board, the dust is kind of clumpy, and it'll tend to stick right there where you're drilling. And if you drill out one hole and you want to drill the hole next to it, well, that hole that's next to it will be covered in dust and you can't see it. So having something to blow just a little bit of air right where the drill is, it keeps the work area clean and keeps the dust off where you're drilling, and you can see where you're drilling. Drilling technique with press like this is it's all about the fine touches. When you're drilling through the board, I've made the artwork so that the holes that are supposed to be drilled through are, you can see them in the pads, the little round openings in the copper, and you take advantage of that when you're drilling. The FR4 board is very, very soft compared to the copper, and when you're putting the bit down on the board, if you use a very light touch and you're inserting the bit very slowly, when you get the bit down to the pad where the hole is, it'll self-center, because it'll cut the FR4 board a lot faster than it'll cut the copper. And if you're using the lightest touch as you touch the bit down on the copper pad where the hole is, if you're anywhere near the hole, it'll kind of move the board a little bit, and you'll feel it kind of pull the board to center it. So if you're holding the board lightly and you're using a light pressure on the press, the hole will self-center in the copper where you have the hole etched. Another good reason to make sure that your holes in the artwork are etched through when you do the etching, because you need those holes to self-center. When you've got all the holes drilled out, it's really handy to have one of those shop vacs, because just a quick vacuum over the board and it'll actually suck out all the dust that gets in the holes, and it'll clean the holes out. And then your board will be ready to put the components through and solder. I've actually been making circuit boards for a really long time. This is the first professional circuit board that I ever designed. Back in 1994, it was for the original Hepcats. I actually drafted this by hand on my drafting table. I had to take the artwork over to the plant where they made the circuit boards, and they rendered it with their big computer onto a CNC for making these things. But it was my first board, and I've certainly learned a lot about making boards just from making them myself. One of the things that I had to come up with to do my own circuit boards, to produce them in volume, was a die system. And this is a typical die. The idea was to drill out a bunch of boards by stacking them up so you can drill a bunch of boards at a time.
I could stack up about 7 or 8 boards on one of these dies and drill them all simultaneously, which cut down the time to make a bunch of boards by a lot. The die, it's basically a piece of 1/4 inch thick aluminum. This is actually pretty workable. I think it's not that hard. It's like a T3 aluminum. It's pretty easy to machine. But it's a piece of aluminum with the drill register. If I get this off. Yeah. See there? Each of those holes is centered on the drill register where a hole is going to be drilled in the PC board, and the holes that are in the aluminum part of the die are enlarged so that when the drill bit goes through the stack of boards and gets through the bottom one, it enters into that enlarged recess. And I set the depth control on the drill so that the bit stops before it hits the bottom so that the bit doesn't shatter. That allows you to have a really smooth drill through the FR4 board, and it doesn't wear out the drill bit because you're not hitting metal. The drill register is put into this piece of brass. You can see it's the drill register. And there are 4 holes in each board that I would have to drill out by hand on every board, but just 4 holes on a board that might have 150 holes in it. And those 4 holes go through pins that are in the die, and those pins are just force fit on the back side. See here. And you'd stack up all of the undrilled boards, the etched boards, stack them up on the registration pins, and then, if I can do it, okay. Then you'd line up the holes, and that top piece would go on top of the stack, and then I would have washers and hold-down screws, and the hold-down screws hold down the stack really tight. And then with the brass guide, it's very easy. You just have to change out the bits for the correct bit sizes, and using the brass guide, it's very quick to just go from hole to hole to hole. You don't have to worry about doing it slowly. You don't have to worry about centering the bit. You just plunge, 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 and within a couple of minutes you can drill out a couple hundred holes very, very quickly. And the die system, allowed me to produce hundreds of boards every production run. This is the biggest one for the Glacier. I had ones for every individual board. Each board has its own die. There's the Vibutron, Vibutron die. This is for the Sweet. That's the Sweet. The famous Peach Fuzz die. When you've got your printed circuit boards all drilled out and ready to assemble, but you don't actually want to go and assemble them right away, it's always a good idea just to put them in a little zip closed bag. It'll keep the oxygen from getting to the copper, and you can store boards like this for years and they won't tarnish. Just keep them in a nice little Ziploc bag, or if you want to go really hardcore, use a Mylar bag, and it'll be even better.
But then I also, when I was in the 1.0, when we did the Sputnik Beeper project, I did show making those circuit boards too, in addition to the 3D printed enclosure and stuff like that. So I haven't made my own circuit boards for a while because we're in an age where it's just not practical to do that anymore, because there are so many companies now that will make you a one-off fab board, either CNC off of raw stock or actually etch it for you. and you don't really have to pay an arm and a leg for it, and they have pretty fast turnaround. So, the need to make your own circuit boards from raw stock for prototyping is long over. So I haven't done it for a long time, but you can do it. You might try it. The t-shirt press is the way to go. I do not recommend using an iron. You just can't get the heat and the pressure. But, if you do decide that you really want to do circuit boards, going in for a t-shirt press is not so bad these days, because you can get them used for, peanuts. You can get, with tariffs, you'll pay more for a new one. But I mean, before the tariffs, you could get a t-shirt press for a couple $100, a really nice one. But you could get a used one for, peanuts. Particularly if you go like on Craigslist, you might find someone local who's got a used one for sale and just pick it up. But that's really the only real specialized tool you need. And you need some ventilation. If you're going to do your own etching, you definitely need ventilation, and you definitely want a vent hood.
In the lab. That's where I work. In the lab. Go berserk. In my lab. That's where I work. That's what you're watching. Friend lab. That's what I'm doing. Working at the bench again.